Okay, this is going to be the video on how I go about making gears. And for this video here, I'll show you first off, if you saw the previous videos, this is the gear I needed to make for my model. And I'm going to show you just a few pics here first to show you what I did and how I came up with a gear design for the model with exactly the same amount of teeth, and how I was able to scale it down to size using emachineshop. I've tried this about 4 times today and had computer crashes, software problems, finally ended up having to buy software to do this. So hopefully this one here works good and I can get this one posted, because it's been a booger to make these videos. So in the next pic, this is the actual gear that I made over here, and it has a gear shape that's very similar to the original gear, and it also has exactly 100 teeth in it that the original gear had. And I'm going to show you how I made the cutters to cut the gear, and then show you in Mach 3 how I set it up to cut 100 teeth in this gear. So in the next photograph, these are the actual some of the smaller gears I made. This little cutter here cut the bevel gear set that I made for the flyweight governor. This here actually cuts splines on a shaft. It's not part of the model project, but that was just another gear cutter, I mean a spline cutter that I made. These three here, before I started using the discs, are the involute gear cutters. I don't know which is which. I believe these two laying here cut the ring gear and the small gear that drives it, the big ring gear. And I believe this one here is actually the one that cut these 3 gears. Now I'm going to show you how to come up with a gear set that you need to the scale that you need, because I needed to match exactly how many teeth were on each one of these gears to what the original steam engine had. So bear with me here a little bit. I'm a stutterer. Okay, here's another view of these, and there's the spline that the spline cutter cut. So we'll go from here now, and I'll show you. Excuse me. This is the design of the gear with 100 teeth that I made in emachineshop. Now, I don't flat cut these gears in emachineshop on the mill. I actually produced, like I showed you, the gear cutter and cut one tooth at a time, and then Mach 3 has the software to turn the 4th axis to produce this gear. This drawing is more for the spoke layout on the actual gear itself and centering the hole up. So I'm going to show you how I go about doing this. In emachineshop, when you click on New, you can pick spur gear, and then you can actually design any gear you want in here. You can change the settings to produce a gear that maybe you have to match a gear, or you're trying to figure out what pressure angle and diametric pitch that you have on a gear that you have that's broken, that you want to reproduce without having to go through all the mathematical equations and everything to do it. So I'm just going to quickly go into how I did this one. I needed to come up with the original gear on the steam engine was 12 feet, and my scale model is 1 inch to a foot. So I needed to make a gear with a 12-inch outside diameter. So there's, in the U.S., there's 3 basic pressure angles. 14.5 and 20 are the common. 25 is there, but I don't believe it's very common. In my particular situation, to come up with the correct style of tooth, 14.5 looked more like the original tooth. Bore diameter I'm not going to worry about, and I'll explain to you why later. I need 100 teeth, so I can go ahead and type that in. And by playing with, I'll show you here. Let me go ahead and hit enter before I get ahead of myself. Now, if you look here, by saying 100 tooth with a 14.5 with a diametral pitch of 20, I have an outside diameter of 5.1. Well, I want a 12-inch gear. So to change this to where it's a 12-inch gear, I need to change the diametral pitch. If you go up with this number, the gear will actually get smaller. The smaller the diametral pitch, the larger the gear. I already played with this. I know what it takes to get the gear I need, and that's 8.5. So I'll type in 8.5. And then backlash is how much play is going to be between the two gears when they're meshed against each other between the teeth. 3 thousandths is fine for what I'm doing. I don't know what it's actually supposed to be. Like I said, this is making these for hobby purposes, but it makes an excellent gear. So I'll go ahead and click OK, and it'll produce my 12-inch gear. It's going to pop up trying to go ahead and make it in 3 dimensions. I don't want to see it in 3 dimensions right now. We're not going to make the gear from what this is producing. We're going to make the involute gear cutter. So the first thing I want to do is actually select the gear itself and just move it out of the way. It takes quite a while because there's a lot of line segments in here. So the more lines that are in the program, the longer it takes for it to actually work from step to step as you're going along. So I'm selecting this blue line here, and I'm just going to delete it out. Then now I'm going to select these blue sections down here, delete them out. I'm going to go ahead and select the gear. Now, all I want out of this gear is one valley in between 2 teeth. That is the shape that your involute gear cutter needs to be profiled at. And so in order to get that, first thing I have to do is ungroup this gear, or it won't let me select just one part of it. Then I'm going to select the bottommost valley, and it's alright to go ahead and take extra. I'll select the bottommost valley. I want to right click on that. See if it'll let me do it. It's moving kind of slow because there's so many lines. Alright, we're just going to go up to edit and click copy. And it copied just what I have highlighted down here at the bottom. Then I'm going to go File, New, move back up to Blank Design, get me a new blank screen. Click OK. Says I don't want to save that gear that I just produced. Like I said, I'm not using that for this purpose. And I'm going to paste this profile in here. Now, the only thing I want actually is this profile right here. And if you were going to grind a single tooth cutter, or in my case, I use that profile to write G-code for a CNC lathe, and I actually make an actual involute gear cutter. So I'm going to go ahead and delete the sections I do not want off of here. Now, this is only the involute gear cutter to fit the 100 tooth gear. The mating gear for this is, I believe, 12 teeth, and in order to make its cutter, I have to draw the 12 tooth gear the exact same way and pull its file out the same as what I'm doing here now. Once I have this profile, you could write the G code and go ahead and have the mill put an end mill in the mill into some stock and have the mill cut this profile on a blank for a fly cutter. I'm sorry, I am tired and stuttering a lot. What I want to show you next is, obviously, this profile is cockeyed, and normally this is the case with the emachineshop. So I'm going to back off here just a little. I don't have to so much. Let's move it back into view. I just want to make it large enough you can see what I'm doing. Make sure that over here your snap to lines is on. Pick up your line tool, go to the bottom, very bottom most left section and click the start of your line and come up, and the farthest left top section will go ahead and automatically light. Put a line there. Repeat that and do the exact same thing on the other side. And I'm going to show you how to straighten out this profile so it's correct for what we need. Put a line there. Now that we have the lines on both sides of this, I want to take these lines and make them 1 inch long so they extend above this profile and actually cross over each other, and I'll show you why in a second. So I'm going to make this line 1 inch long, and I want to make this line 1 inch long now. Now from here I want to draw a line across the top of these two lines and read the angle this is at. This is at 4.12 degrees. So this profile is sitting 4.12 degrees past, I keep getting in this error, I don't know why, past 0. And I want the profile setting at 0 for my uses. So the way to correct that problem is go to Edit, select All. Now there are, if you look on the side here, there is Control A, Control F, Control V, F2. There are key functions that you can do on the keyboard to do these things faster. I don't do that when I'm demoing it because I think it's a little more confusing. It's better to just go to that actual selection and select it. So I'm going to select all. Then I want to go into line, and I'm going to transform this line by rotating it. Now since it's beyond 0 by 4.12 degrees, I want to subtract minus 4.12, I believe that was the number, 4.12, and click OK, and you'll see that now it's rotated everything in the picture and in the drawing, and it has straightened it out. If you click on the top line now, it's sitting at 360, so that means this profile now is usable and it is straight up and down. These lines that we added to do this, we're going to take out, and then from this profile I can produce the G code. I have to do it in other software besides D2 and C for the CNC lathe, and I'm not going to go into that at this point in time. You could, like I said, use this profile with D2 and C and cut it in for a single point cutter for a fly cutter. Now what I'd like to do is, once you understand this profile and we've made our tool, let's say we've gone that far, I'm going to go to Mach 3. I'll go ahead and shut this down. I don't need to save it. And I'm going to go into Mach 3 and show you then how we set up Mach 3 to cut this gear on a 4th axis. If you don't have a 4th axis, you can do it manually. Make your tool, divide it up. I don't know how to use an actual rotary table in that sense. I didn't buy all those tools. I went CNC. So going to Mach 3. I'm going to select mill. There was one thing that I forgot to do when we were back there on the drawing, and I'm not going to do it right now. If I would have drawn a line across the opening at the bottom of that profile I was showing you, and then a line straight up and down through the center of it, that would have measured the total depth of cut that we're going to have the tool that we made cut into this gear. You'll need that. I should have done it. To get Mach 3, this is not hooked to a machine, so to get it to run I have to hit offline and reset. And if you go up into the wizards, you can pick these are actually some of the free wizards. Newfangled and some of the other ones cost money, but if you can, gears and splines, you can search for these. I'm going to run this. Okay, it's asking me first off if I'm going to cut a spline or a gear. I'm going to cut a gear. Okay. At this point, you want to restrict the Z movement. So once you've actually set Z and you have it zeroed with the center of your blank, then you can use this so nothing mistakenly moves Z. It's a good idea to do it. Next, it wants to know how many teeth. We have a 100-tooth gear. It wants to know the cut feed rate. So we're just going to, I'm sorry, you have to hit enter. You're learning by my mistakes. I'm going to put a feed rate in at 10. We have a plunge feed rate here, which does, I don't plunge in on the material. It's actually going to be completely out of the material on each pass. So I'm just going to set it the same 10. I don't need a reduced plunge rate for that, and hit enter. Okay. Y is going to retract quarter of an inch. I actually need no, that's fine because that's a quarter of an inch from the face. Full depth of the cut, that's just luck, is going to end up a quarter. My tool diameter is, in this case, 2.0. I have to hit enter. X start position is 2 positive. Stock diameter here, well, let's put this in quick, 12 inches. Enter. X feed distance. Okay, X start position. I'll start an inch from it. So, and call that 0. And I will feed 3 inches. Just as an example, I would actually line up the cutter and see where it's clear on one side, just as it clears enough for the gear to turn. And when it's clear, when it's made a full pass to the other side, whatever distance that ends up, you want to make this as short as possible because it adds time to your actual probe. So we're just going to say 3 inches for this purpose. So at this point, you can set your tool number, your spindle RPM, spindle direction, whether this is inch or metric, whether you want it to turn the coolant on. Okay, that's the feed and cut rate that I would probably set this to cut this gear. It matters what the material is, obviously, but for these purposes, I'm going to save our settings. And I'm looking for depth per pass. And I'm missing something here. I haven't been in here for a while. Retract, full depth, step depth. Okay. Full depth is 0.250. Enter. And varying on how rigid your machine is or whatever, but I'm just going to put in a, let's say a 10 thousandths per pass, make it pretty smooth, and hit enter there. Okay, so we got a full depth of that quarter inch I said we got by measuring. We're going to take 10 thousandths per pass. Our tool diameter is 2 inches round in loop gear cutter. We're going to move 3 inches of total travel on a 12-inch gear. We're going to cut 100 teeth into it. So we're going to save our settings, post the G code. Start position equals 13. I'm missing something. Maybe not. Let's exit. The last couple of times I did this, I used newfangled solutions, but it's a little more drawn out. Let's see if I can really get an idea of what we're doing here. On the gear cutting tool pass, it's hard to see what they're doing. Okay, we are looking face down on this gear. So it's kind of confusing, but I'm going to hit cycle start. You can see it go through. Go back to program run, and I'm going to speed this up. till it regen. It's just the display is funny. Um, it will make each pass until it has each tooth cut to its full quarter-inch depth. Then it will turn the fourth axis, and that's basically what I'm waiting for you to see. I could have put the depth a little higher and actually had it cut each tooth in 2 passes so you can see it rotate the uh, the fourth axis. But let me do that real quick. I'm just going to go back to the wizard. Pick the last wizard. Okay, it's where were we? The full depth's 0.25, and let's make this. Let's just make it 0.2. It'll cut each one in 2 passes. Okay, save settings. Post G code. This is just for demonstration purposes. So now it's going to cut the teeth 2 passes, turn the fourth axis 2 passes. Okay, this is another thing that mocks. I need to unload the code that's in there. Okay. Mach 3 does not like Windows 7 at all. I have more gears and splines. Run. Let me come back in and regen this. I'm in my house and okay. That should be what we need. Mach 3 runs its best in XP, but I'm just doing this in the house for demo. Alright, now let's see if I can zoom in on this a little better. We'll zero this, regen it. Alright, now I'm going to hit cycle start, and you can actually see it make each pass. Except for like I say, this is just not knowing this particular version of the gear cutter. But you can see that it is now going to make 2 passes and rotate for each tooth. Trying to understand why it's showing that it's moving Z. It shouldn't be moving Z at all. It's making a pass above and below the center line of the 12-inch gear. So I guess that's probably the way this software is designed. Yeah, it's taking it off one side and then taking it off the other side, but it's doing it way too much for what I'm seeing here. I don't really understand that. I probably forgot to tell it to lock the Z. It's an error on my part, I guarantee you. But this will sit here and continuously run until it has cut all 100 teeth. And that's it for this video. If there's any questions about gear cutting, especially if you're trying to match a gear that you have, maybe a missing gear, or you're trying to determine the pitch and what gear cutter you need for a particular gear, get a hold of me, ask me, or review this video and go into emachineshop, play with the numbers in the gear maker, and even a bevel gear, if you're looking at it face on, you can determine what the module number is to cut that gear. So that's the end of this video, and thank you for watching.